Greetings everyone, and welcome to the next video in my lecture series on differential equations. In this video, we will use the derivative of a Laplace transform to solve an initial value problem. So our example is we're going to solve the first order differential equation y prime minus y is equal to t e to the t sine t with the initial condition that y of 0 is equal to 0. So before we get started in taking the Laplace transform of both sides, let's remind ourselves that the Laplace transform of t sine t is equal to 2s over s squared plus 1 all squared. In other words, the Laplace transform of t sine omega t is 2 omega s over s squared plus omega squared all squared, but here our omega is equal to 1. And what we're then going to consider, we've now got almost all of the parts of the right-hand side, and the e to the t part, which we've omitted thus far, makes every instance of s get replaced by s minus 1, because multiplying a function by e to the at shifts its Laplace transform by s minus a. And so we can conclude from that that the Laplace transform of t e to the t sine t is going to be 2 onto s minus 1 over s minus 1 squared plus 1 all squared. And you could multiply that out if you wanted. I'm not going to bother. A different way to handle this, if you prefer, is looking at the t e to the t times sine t. If you prefer to not use the Laplace transforms table to find t sine t, which we found previously using that derivative rule, you could also take the Laplace transform of e to the t sine t and then take -1 times the first derivative of that. I think that the shift is a little easier, so that's how I'm going to handle it. So back to, whoops, let me try to write not with my highlighted pen. So let's go back to the differential equation. If let's write that out actually, because we've already forgotten what it was. Y prime minus y is, y prime minus y is equal to t e to the t sine t. Then taking the Laplace transform first of the y prime, that gives us s y to the s minus y naught, y of 0. That is that entire thing inside the square brackets is equal to my y prime. And then the Laplace transform of lowercase y is just capital Y of s. And then we showed above that the Laplace transform on the right-hand side is 2 on s minus 1 over s minus 1 squared plus 1 all squared, which looks kind of terrible. But let's remember that our initial condition, the initial condition was that y of 0 is equal to 1, and that means that this term goes away. What we're left with on the left-hand side then, if we factor out the y of s, is s minus 1 in brackets times y of s is equal to 2 onto s minus 1 over s minus 1 squared plus 1 all squared. And looks kind of terrible that you're going to get a complicated partial fraction thing, except that the s minus 1's very conveniently cancel here. And we're left that y of s is equal to 2 onto s minus 1 squared plus 1 all squared. So what do we do with this? We're going to take the inverse Laplace transform of both sides. But let's work on the right-hand side first and say that now the s minus 1 gives a factor of e to the t from the shift. And if we look at what we have on the right-hand side, it kind of looks like 1 over s squared plus omega squared all squared, where the e to the t takes care of the s minus 1 part. We've just got a factor of 2 out front, and if we write what the inverse Laplace transform is, it's one of the entries on your Laplace transform sheet. You get sine omega t, which is just sine t, minus omega t minus omega t cos omega t, so I'm just going to get t cosine of t divided by 2 omega squared, and that just gives us 2. Oh, wait a minute. Let me actually write out the whole thing because I was using omega here, so it's going to be sine omega t minus omega t cosine of omega t over 2 omega cubed. That's from the Laplace transform sheet. And then that allows us to know that the inverse Laplace transform of 2 over s minus 1 squared plus 1 all squared will give us 2 e to the t. The 2 comes from the factor up top. The e to the t comes from the shift. And then we're just going to have, oh, let me write in red here, sine t minus t cos t over 2 omega squared, which is just omega cubed, which is 2. Notice the 2's are going to cancel here. And so then y of t is just going to be e to the t onto sine t minus t cosine t, like so.